Today I'll be talking about experimental archaeology for learning lithic techniques. So how is it beneficial? What can we learn from it? And some case studies as well. And then at the end of the lecture, there's about a 10-minute video which my student Vivek Singh demonstrates making a Handaxe. So just to get some ideas how you can go about getting into experimental archaeology and its benefits. So I just want to give a broad overview that we have many human species in the past. When I say human, I mean hominid. Most of them are not in our lineage, and some were in our lineage. We have 6 genera, over 30 species reported, but there's disagreement about which are our ancestors, which are not our ancestors, and there's a lot of spatial and temporal gaps in the record. So we don't exactly know the full story, and we keep finding new discoveries that constantly change our hypotheses. And keep in mind also that all these species were making different types of stone technologies and also non-stone technologies. But because stone has survived, we call it the Stone Age. But they're probably using other materials like wood and bone more than stone. So we have these technologies starting at 3.3 million with Lomekrian, and then it continues to Oldowan, Acheulean, Middle Paleolithic, Upper Paleolithic, and Microlithic. Now, not all of these have transitions. For example, there's no clear transition between Lomekrian and Oldowan. Lomekrian, we only have one site, and then between 3.3 million and 2.6 million, there's no archaeological evidence. But from Acheulean, 1.7 million or 1.8, the evidence is continuous. But then after Middle Paleolithic or late Acheulean onwards, there seems to be regional origins, multiple regional origins, not just one single origin. And then we have timings of invention on the left and timings of dispersal from Africa on the right. But still a lot of evidence is not clearly known, especially Asia, India, for example. More research has been done in Africa and Europe. So the multiple uses of prehistoric archaeology, what can we learn from Stone Age studies? We can go beyond technology, we can go beyond stone tool descriptions and typology. We can learn many things about sociality, language, cognition, adaptation to different environments, association with fossils, the beginnings of culture, transitions of culture, population replacements. There's many things we can actually learn and use in prehistoric archaeology. We can go beyond stone tools. So just an overview of past examples of experimental studies in India, which universities or people have done them. MS University of Baroda, Deccan College in Pune, Allahabad University, the Sharma Center for Heritage Education, and then various foreign scholars have done experimental research, Shipton, Aaron, Canoyer, and others. So these I'm just talking about broad known studies or published evidence. There's probably a lot of unpublished data and unpublished experiments that have been done by many people. And today there's quite a few interested knappers, and some of them are very good. So why knap, and why use stone tools? As archaeologists and anthropologists, what can we benefit from this exercise? The first thing is we can better interpret archaeological evidence and test specific hypotheses or research questions. There's a lot of evidence we're finding from excavations, but we can't always answer it just by counting and measuring and describing. If we knap stone tools and use stone tools, we can get more insight into the archaeological evidence. Then we have typology, technology and reduction sequences, the actual chain repertoire, how things were made exactly, what the techniques were, why did they choose specific raw materials, for example, why did they make specific tool types, did they merge into one another, or were they specifically targeted from the beginning, what were the accidents, what were the mistakes, what was the learning process. Then we can differentiate between hominin flaked and naturally flaked specimens as well from some sites. If some sites are ambiguous, we can do it in the lab and confirm. Then we can also see the physical differences between different rocks. for efficiency, for class constraints, and other properties. For example, what is the difference between basalt and quartzite, or between quartzite and granite? How does that affect tool typology and tool efficiency? Then we can understand things about cognition and motor functions, including mental templates, planning, techno-complexity. We can use different techniques for this, like brain imaging, for example. Then we can look at functional efficiency of the artifacts and the purpose of specific tool types. For example, Handaxe versus cleaver, or different types of scrapers or choppers. We can look at microscopic analysis, we can do a microscopic analysis, we can do use-wear analysis to understand exactly how and why these stone tools were used. Then also looking at the ergonomics or holding patterns for specific tool types. How are the tools held? Which muscles were being used? Where were the pressure points being put on? So all these things tell us about the evolution of the hand, evolution of the arms and upper body, and of course brain development in conjunction. Then also degree of modification on other materials. How did other materials get affected by stone tool use? When you're cutting meat from a bone, how does the bone get modified? What kind of marks appear? Where are the marks preserved on the bone? And then also wood. How fast can wood get destroyed or cut by using rocks? How long does it take to scrape leather, for example, or hide? And then use of knapping space also, individual sitting postures. So if a person is sitting on a chair or sitting on the ground, you're going to get two different type of stone tool scatters. And then also distance of debris spread. So what is this, when you're sitting and knapping, what is the actual size of the lithic scatter you're creating? Is it like 4x4 meters or smaller or larger? And is it different with blade technique? Is it different with making bifaces? How are each of these different? And the nature of social transmission during teaching and learning sessions as well. So older technologies are very simple, and one can learn them just by watching an expert. But as we get more complex technology, like late Acheulean onwards, we need to use communication or language to teach the novice. So that's where language and communication comes into play. And we can also learn about that, social transmission. And also speed of self-learning. If you're teaching yourself, how fast are you learning? Are you recognizing the mistakes? Are you recognizing the wrong angles? How fast are you correcting yourself? What is your progress? And this is just a broad overview of what we can know from making stone tools. But there's probably many other things that we can address. So I'll just show you some images in relation to what I just covered. For example, we can understand the fracture mechanics of different rocks. We can see the different properties, which rocks flake easily, which rocks you need more strength, for example, and how do these rocks compare with each other when they fracture. And then what do flakes look like? Different flakes coming out of different rock types. When you change the angle, when you change the force, when you use different hammerstones, for example, there's many, many different ways we can find out the reasons for variation in these types. And then what kind of flakes are coming out? How do you take out an end flake? How do you take out a side flake or an oblique flake? How do flakes get split or snapped? Is it always during the knapping process, or is it done intentionally afterwards? Again, just to test different hypotheses. And then looking at Handaxe symmetry, both bilateral and plant form. Now we know from preliminary experiments that symmetry of Handaxes was not more functionally efficient. Even asymmetrical Handaxes were equally functionally efficient. So why were they making them symmetrical? Was there a mental template? Were they going for aesthetics? Was it to attract mates? We don't know all these things, but we can get more insights by looking at different raw materials, different types of Handaxes, and going for symmetry, asymmetry, and see how Handaxes evolved over time. Then Handaxe shapes. Why are certain shapes more dominant in certain regions? For example, in Europe, it's dominated by ovate Handaxes. There are no cleavers over there. So why are certain Handaxes dominating? Why are other Handaxes occurring marginally? What is the reason behind this variation? Is it just culture, personal style, preference, function, ecology, what? And then how do these large clasts get broken? Sometimes large rounded boulders need to be thrown on an anvil. And this is what they look like. You see a Hertzian cone formed by the force of the throw and impact between core and anvil. So these are hints that a lot of force was used. Maybe it was thrown on a boulder, or maybe a large hammerstone was used with 2 hands to strike the core, for example. And then angular fragments. Sometimes if you find these in the field, we'll just think they're natural. There are no characteristics. There are no bulbs. There are no ripple marks sometimes. So it's not clear if they're always natural or artifacts. But from experimental work, by throwing clasts on anvils, we can get an idea of the pattern of fracture. And then debitage as well, a small debris that comes out. It can be angular debitage, it can be small biface thinning flakes. Different types of debitage tells us different things. The first thing it tells us that if we find debitage is that the site is relatively less disturbed, and we can use this information to talk about the manufacturing sequence. It suggests that it was a manufacturing site or a factory site. So a quarry site where raw material is extracted and a Handaxe production site, for example, would look different. And some sites would have debitage and some sites would not have debitage. So debitage, even though it was discarded in the past, is very important for archaeologists. In fact, you can see entire books have been published on debitage. And then different flake types. We can understand the sequence of knapping. The more cortex, which is the outside surface, the more cortex there is, that means it's early stage of knapping. The less cortex there is, that means it's the inside of the core. So this can be applicable especially to Oldowan assemblages or core and flake assemblages on rounded material. Less so with mode 2 technologies and younger ones, because not always do these cores have cortex. And the other benefit of cortex is that it helps archaeologists carry out refitting studies. Refitting tells us a lot of information. Number one, what was the sequence of knapping to make any tool type? Which flakes were taken off first, which were taken off last? What was the actual sequence by refitting the entire core? Second thing is that we can see how the space was used, how much the site has been disturbed. Are the refits close to each other within 1 meter? Are they within 10 meters? What processes led to these disturbances, for example? And how long did it take for that scatter or accumulation to become deposited over time and preserved? And then looking at shapes, different types of raw material. We have quartzite cobbles and pebbles on the right from shivalics, and on the bottom we have these angular blocks of limestone from Karnataka, South India, from Hundsgi Valley. So how are these exploited? One region is dominated by Sohinian type assemblages, and one region is dominated by Palaeolithic assemblages, very diagnostic ones, and including Handaxes and everything. So how are these used? Does angular raw materials versus rounded raw materials make a difference in understanding the pattern of archaeological occurrences? And then we have rounded ones. How are they exploited? Just because they're round, does that mean they could not make bifaces? For example, here we have possibilities of how rounded stones could have been used to make Handaxes and cleavers. So it's not that there were always raw material constraints. Sometimes there were knapping strategies or limitations that just modified these typologies a little bit. Here's an example of things that look like bifaces, but actually they're unifaces from Sumerian assemblages. And this shows that they were using a facial flaking strategy, just like in Acheulean. But no typical Acheulean artifacts are known from shivalics, from Sohinian. Then we have the degree of use: hammerstones, choppers, pounded clasps, core scrapers, all these heavy-duty tools. How are they used? What was the nature of their function, for example? How long were they used? Were they used for 1 week and discarded, for 1 month, and then where they turn into other tools, for example, once they became blunt. There's many things we can see, like compare between utilized edge and a very sharp edge on the right. And then microflaking, how does it appear? When we're cutting wood, for example, with a cleaver, or scraping something with a thin handaxe, what are the marks that are made on the edges of the artifacts, and what kind of step flaking happens? Is step flaking only from utilization, or is it also from retouch or edge damage? How are these things actually forming on different specimens? We can find out by replicating them. And then different tool types from lower Paleolithic onwards, they have different functions. Of course, you can use a chopper for scraping and chopping, but a scraper is better for scraping than a chopper. It always depends on the context, on the function, on the raw material, on the limitation of that tool type. Also, it depends on the skill of the user, for example. Maybe a specific expert can do many things with a flake that a novice cannot. And then, of course, you have to keep in mind that some tools, like large handaxes, will gradually become smaller and smaller over time by using them, resharpening them, and then reflaking them, recycling them, and then turning them into scrapers, for example. So sometimes bigger tools might have ended up as smaller tools. So you have to keep this in mind as well. It's not that small tools were always primary targets. They could have been secondary targets over time. Here's an example of how pebbles and cobbles are used as hammerstones. And most stones are called hard hammers, except the soft stones like sandstone, for example. And then compared to soft hammers, these are antlers. So hard hammers are used for direct percussion in initial stages of biface manufacture, but then soft hammers are used to refine the biface, to take off longer, thinner flakes and control flaking. Because antlers and wood and all these other soft hammers, they absorb the shock better, and you can take off long, thin flakes across the specimen. But the hard hammers will take off short, thick flakes. So different hammerstones and different hammers have different functions. Then thinning flakes, resulting from soft hammer use. Trying to thin a core or a biface, anything, even a scraper. You get thinning flakes showing that they prepared the edge with grinding it, for example, and then hitting it with a hard hammer or hitting it with soft hammer. It depends on raw material to raw material. It varies how these flake morphologies are different. Then we have an example of direct percussion, where the hammerstone is striking the core directly. So this is one of the most earliest and most common forms of knapping. This is how it started. The earliest technologies, for example, even before Oldowan and Lomekwian, the technology started with percussion, taking a cobble and smashing a bone. So the earliest stone tools probably were not modified. They were just picking up a natural rock and using it directly without modification. So direct percussion started slowly, percussive technology. And then gradually it leads to indirect percussion, a third component. So it could be an antler, it could be a piece of wood. So positioning it properly between the hammerstone or hammer and the core. And then of course another indirect percussion component could be anvil, putting the core on an anvil and then striking it with the hammerstone. And then comes pressure flaking. So all of these techniques are appearing over time. The longest surviving is direct percussion, and then indirect percussion starts, then soft hammers also appear, then pressure flaking mostly starts in Upper Paleolithic onwards. So we have applying pressure with antler, for example, with wood, and then gradually in the Bronze Age, we have tools made of copper. So copper billets are being used to apply pressure on the stones to take off tiny little flakes or long thin flakes or blades to get specific type of artifacts. For example, these type of artifacts. So Solutrean technology, for example, a lot of the North American point technology, These specific technologies utilized pressure flaking mostly, initially roughing out with percussion and then gradually leading to pressure flaking. If you tried percussion on these artifacts would snap. The only way to take off long, thin flakes, very thin, is pressure flaking. And ultimately, the points that are made, salutary points, they're just a couple of centimeters thick, sometimes less. So when we get information from lithics, usually it starts in the field, for example. We can have field collection, or sometimes we can also study as something collected by somebody else. So there's a lot of material already sitting in go-downs, already sitting in labs and museums, and unstudied, unpublished, and those can also be studied. But if you're bringing it from the field, you would have a proper systematic protocol where you'll bring it to the lab, you would wash it, label it, catalog it, draw it, photograph it, and then you would start analysis. And you would analyze these artifacts in many different ways, measuring, weighing, describing, classifying, and then comparing them, of course, with other assemblages. But experiments, carrying out experiments, is one small component for studying lithics. It's not the dominant one, and sometimes it's not possible to do, sometimes it's not necessary to do. It depends on what research question you're answering. Each and every project doesn't have to have an experimental component, but if it does, you will get more insight from the archaeological evidence. And ultimately, the final stage will be publication of the data and public outreach. So interacting with the public or the local community and trying to understand the relevance of all this material and our work. It's just general attributes, the qualitative attributes you would study, and quantitative attributes. And these attributes can be used both on archaeological specimens as well as experimental specimens. So qualitative are not measurable, but still important. For example, the condition of the specimen, the presence of retouch, whether it's edge damage or not, what is the edge shape, what is the typological classification, whether it's a hand axe or a cleaver, facial scraper, for example, or a knife. And then quantitative attributes, where they actually measured, or the things are counted, like length, width, thickness, and then number of flake scars, for example, the angle of platform when during striking, the amount of cortex retained, the weight of the specimen, the degree of symmetry, and all these things you would apply with statistics to get patterns and see how these things compare. It helps when the sites or assemblages come from primary context, because if you have mixed context, then you're not going to get meaningful information. You're not going to get information about human behavior. Ultimately, the reason we're doing this is to get patterns of human behavior, not just get numbers and make graphs and just generate data. That's not the goal of archaeologists studying lithics. We have to get information that leads to understanding past human behavior. So now I'm just going to give you a few examples, for example, of how experimental archaeology can be done in the right way, can be done in the wrong way, and where it should have been done but wasn't done. So the first example is addressing a long-standing notion that Neanderthals were robust because of the climate they lived in and associated subsistence behaviors. For example, Neanderthal bones and skeletons, from that information we have, they have larger and thicker and more robust forearms than Homo sapiens. And the long-standing notion was that this is because of the climate they were evolved in, especially glacial environment, and because of constant hunting action, this thrusting action with the thrusting spear. So this was a hypothesis. But then gradually there were experiments done with scrapers. Because they were living in glacial environments for a long, long time, they're required to make leather hides. And for that, they required many, many scrapers, thousands of scrapers. So from experimentation, we found out that which muscles get affected by constantly scraping. So the arms of Neanderthals are robust not only because of spear use or climatic reasons, but because of scraping actions. So scraping actions and other tasks, similar tasks, leads to robust forearms. And experimental archaeology helped prove this. So this is a rare example where archaeology helps understand biology or anatomy. Another case study, this is important because I would like you to know that experimental archaeology doesn't always take place in the lab. You can also do experimental archaeology outside the lab, in the field. For example, here the researchers looked at experimental stone tools and their impact by trampling of animals. So in dry sediments, in moist sediments, how did these lithics get affected by trampling by the buffalo and also goats? For example, how disturbed did the site become? How scattered did the lithics become? How many lithics broke, snapped? How many lithics sank into the ground? And then how many lithics were reoriented? So the graphs you see on the bottom, these are rose diagrams, and they show that before trampling they were horizontal, and after trampling they were diagonal or vertical. Now this information is used to interpret context of the artifacts found in excavations. Many sites now are yielding artifacts in different orientations. What is the reason behind these orientations? And the other information that you get from this is how the site formed. You always have these processes acting on sites after abandonment by hominids. So how did these things get affected? So this is an example. Another thing you can do is maybe carry out experimental butchery near a river, and over time see how the river flooding affects the reconfiguration of the lithic scatter and the bones. How much is the site destroyed? How fast is it buried? If it's buried, does it stay buried over 1 year, or does it get re-exposed? There's many things you can use, geology and geomorphology and lithics, and combine these things to understand site formation processes in the field. Now this is an example of how experimental archaeology can be used in a wrong way. Now a few years ago, a team reported these cut marks, and this is a specimen, one of the specimens in the center, in the red box, with cut marks on the bones in the Shivalix at the site of Masol. Now these were thought to be made by hominid stone tools, and they're estimated to be 2.6 million years old. And these specimens are on display in the Chandigarh Museum. Now, they carried out experiments to prove that the archaeological evidence is made by stone tools, because you also have other processes. For example, crocodile teeth, the teeth of a lion, all these predator teeth, or if the bone is getting transported in the river, all these processes can leave marks similar to those made by stone tools. So it's sometimes very difficult to distinguish them. Stone tool marks versus crocodile teeth marks, for example. So they carried out experiments, but the problem was that the stone, the fossil evidence is on a bobbin. But they carried out their experiments on deer and pig bones. So now you have two different types of analogies which are not suitable for the archaeological evidence. So you have a deer carcass they used without any meat. So cutting a bone without any meat, the cut marks are going to be different. Those are intentional. And then also pig bones are very soft. So using pig bones using pig bones and deer bones is not the right analogy or proxy to compare with archaeological evidence. There's a mismatch. They should have done it on buffalo bones, for example, or cattle bones with meat. There was various ways to make it more authentic and original instead of using these methods. And then an example of where experimental archaeology could have been done, there was a lion figurine, alleged lion figurine, reported from Kerala, made on quartz. And this was supposed to have been found with non-Acheulean lower Paleolithic tools. So just core and flake tools, or chopping tools. Now the methodological problem is that it's impossible to carve quartz using quartz, as the author stated. The author stated that it was made by quartz on quartz. But for now, no such studies have been done. And second thing is, no experimental work was done to test this, whether a quartz nodule can be modified using another stone, including quartz. Here is the alleged lion figurine, which I personally don't see a lion here, but that's what it was reported in current science. But this is an example of where experimental archaeology should have been used to confirm whether quartz or any other stone can help carve quartz. So just to conclude now, slowly, last few slides, there's some things we should know about experimental archaeology that we don't realize when we're actually doing these things. There's a difference between experimental archaeology and experiential archaeology. When you're just knapping for the sake of practice or not for any specific academic purpose, it becomes experiential. But then if you're doing it to address a specific research problem, it becomes experimental. There's also limitations and dangers of experimental archaeology. For example, there's some information in the past we'll never know. For example, if there's a site with Handaxes, who made those Handaxes? Men or women? These things we'll never know through experimental archaeology. Although we can compare, it's possible that one woman will make Handaxes differently and one guy would make Handaxes differently, and they might not be able to compare with each other. It depends on everybody's personal techniques, strength, skill, experience, quality of raw materials. There's many factors that affect the final product. And we can't automatically use experimental results to interpret the past, especially with the further back in time we go. If we're replicating things today, many things have changed in the past. 1 million, 2 million, 3 million years of evolution have taken place. So if we replicate things today and use them, their functions will be different than in the past. Some things we'll never know what the intention was and how they were using those stone tools. We can only hypothesize and guess. And we can't use regional results to generalize about other regions. If I talk about making Handaxes from Shivalik raw material, I can't apply that information to South India, for example. Or I can't use Indian evidence to talk about European evidence. Each region has to be taken independently. Each raw material has to be viewed differently, even quartzite, because there's a lot of variation in quartzite across India. If you can't replicate it, we can't properly explain it. If you can't explain it, then we can't properly understand it. And finally, if you can't understand it, we can't interpret or accept it. So if there's any ambiguous specimen in the archaeological record, and if you can't interpret, the best way to do it is replicate it. Try to understand where it fits in the sequence, what the function was, what its purpose was, and then we get better insights. And also, if you don't publish your results, then it becomes a hobby and not research. A lot of people do it just for practice, just as a hobby. For example, in North America, knapping is a hobby with hundreds of people. They get together at conferences or at meets and just do knapping, but they don't publish. That's not their intention. It's just to replicate stone technology or primitive technology. Except teaching purposes. When you're doing something and replicating things to teach, that's when you would not publish necessarily. But you can also publish those results and see how you taught somebody else. So some Indian research question that can be answered through experimental archaeology: what kind of subsistence behaviors does the Indian record reflect? What was the function of specific artifacts? We can make them, use them. What was the link between different assemblage compositions and diverse raw materials? For example, make an entire toolkit from basalt, then from quartzite, then from granite, from dolerite, and then compare them. See how they look, see how they function, see how fast each of them wears down, for example, which are more durable, which are less durable. Were some raw materials more efficient than others, so it can be tested? And can we also understand or generate transitional lithic evidence through replication? From getting a knapping sequence and making different tool types, advancing our knowledge and skill over time, can we understand transitions between technologies by replicating and learning from our own experiences? What are the explanations for the absence of specific tool types in some regions of South Asia? For example, Handaxes, projectile points, polished axes. These diagnostic tool types are missing in many regions. So what we can do is maybe use those raw materials from the regions they're missing in and try to replicate these tool types. Maybe we might find out that they're missing because the raw material is not suitable, or there could be other factors. So maybe the raw materials were not exposed during human occupation, or the climate was not suitable. But experimental archaeology can be a small factor in getting the whole picture properly. We need to go beyond beyond Handaxes and points. A lot of people who start knapping, the first thing they want to make is a Handaxe. It's human nature. Maybe it's in our DNA, in our mental template. And then they go on to make points. But we should also focus on other tool types. There's cleavers, scrapers, blades, burins, microliths, ringstones on the left. So there's many tool types we can actually make and understand the full spectrum of Stone Age technology, and not just bifaces. For example, we can make these different tool types. You see choppers, scrapers, typical Sumerian artifacts. And on the right, these indented anvils have been found. And we don't know the function. They're three-sided. The entire specimen, if you look at the cross-section, is triangular. And almost each side has two indentations, two depressions, from being used as an anvil. So what was it being used for? For nut cracking, for something else? We don't know this. So we can answer specific research questions by experimenting and replicating these things and getting a better idea. This is just an example of going beyond Handaxes. And we also need to go beyond stone tools. We have so many other options for experimental archaeology. We can reconstruct a megalith. We can address things in symbolic behavior, for example, rock art, like paintings, making ostrich beads, ostrich eggshell beads, engraving ochre, making bone tools, making copule marks. There's many tools and artifacts we can replicate to go beyond stone. So this is very important. It's not being done enough, in my opinion. Now I'll just play the video, which is showing about 10 or 11 minutes of Vivek knapping. And you see it's an edited video, not the full video. The full video, actually, the full time it took to make this Handaxe, I would say it's about half an hour. But we're just going to show you 10 minutes. And then at the end, I'll show you the photograph of the final product.
Hello everyone. Today we are knapping and trying to make a Handaxe out of these two blanks. They both are quartzite and they are flake. This is the ventral surface of a flake, and this here is the dorsal surface. It's the cortex. And for this we are using various hammerstones, like these four hammerstones are of quartzite, and this hammerstone is of granite, and this here is a brader stone, and it's a sandstone cast. So before we knap, safety is very important. So you should always wear glasses to protect your eyes, and you should always wear gloves, so you shouldn't cut your hand, and a leather pad if you nap using your leg as a support. So you should always have something like this, and you should also wear shoes or any kind of protection in your legs, because when you nap, the flakes can go anywhere and it can hurt you badly. So let's start napping, and we'll use this last. Let's see how it works. So first, as you can see, these edges are very sharp, so we have to abrade them before taking out a flake, because if we try to hit here, it will only crush the edge and we cannot take a bigger flake from this edge. So we'll just batter this edge And when you proceed to knap, you should always have a clear picture. So what you want to make and what shape, what size, and yeah, let's just start. I guess we can still take one or two flake from here. I'll try to hit here and take this flake from here. Okay, so it wasn't that clean hit, but I took some of that what I expected. I expected a bigger flake, but this is also good enough. So you should always choose your Handaxe, your hammer stones, depending on what kind of flake you are trying to get. And it's important to have multiple hammer stones while you knap. So this here is kind of a thinning flake, since I didn't prepare it that much, but it did what I wanted. So this is what we call thinning flakes in hand axes. It just remove the basic thickness, and you can see from here, before taking the flake it was this thick, and after it's quite. You can see a thin, very thin platform, and then it took this much of the thickness. Means you can see how thick this flake is. I'll try and take this flake from here. Actually, these two are the high points here on this flake, and first I'll try to remove this, and then I'll try to remove this, so that it becomes more refined. So here I'm just preparing the platform. The angle is not good enough here, so it's just breaking the platform. So it's too thick here. Yeah. So see, this flake basically came out because of the shock wave which were created when I hit here. There is some kind of fault here, because every flake which I try to take, it's just ending up in step. So We'll try to remove this, but from another angle. Let's see if we can get this from here. Oh, the hammerstone broke. See. So we'll leave this portion for now and just focus on other edges. More or less, it's a rough out kind of thing for a hand axe. So let's just move towards refining it. This fault is difficult to remove, so we'll just leave it here and actually shape the hand axe into like proper form. Okay, so this here, it's almost a finished hand axe. So we do have this ugly side here because of the fault here, and we can still remove this, but by doing that we have to compromise the size, means the length and the width too. So we're gonna leave it here, and here we have a hand axe. So here, and there's a big I took a big thinning flick here, so I was trying to take here, but it's okay. And this side is not that well prepared for like cutting or anything, but here we have a straight edge, thin straight edge with and we can do various things like cutting, scraping, even chopping with this. And this can also work as backing, so it won't cut your hand if you hold it like this and use. So this is just the rough form of hand axe. If we invest more time and more hours, we can make better hand axes. And even if I use soft hammer here, soft hammer means like a hammer made of antler or wood or any other soft stone, even like sandstone. So by doing that, we can take these longer flakes, thinner and longer flakes, and that can actually reduce the thickness to a very to a more refined hand axe. So that's it.
So this is the final product. Vivek spent another I think 10-15 minutes finishing that with a soft hammer, and basically it involved trimming, thinning, and shaping alternatively, kind of turning over the artifact, looking at it from different angles, working on different edges, and then keep changing hammer stones and finally until you have the product. But I think it's slightly smaller than what he intended, but it's still a very good specimen, and it serves the purpose for whatever one wants to do. The two faces are visible here in the lateral view. And that is the end of my talk. And I've also given my email address and Vivek's email address in case you have more questions later, or if you need any readings or something, feel free to contact us. And now we can have